There was a time when physicists genuinely thought they knew everything. They threw experiments at Newton's laws and they stood up to amazing accuracy. The seemingly separate fields of electricity and magnetism were unified. The idea that everything is made of particles seemed so elegant that they thought physics was complete. For now, these are particles and these are waves. Okay, now that you know as much as physicists knew in the late 19th century, we can have fun with some physics. Except physicists didn't know everything. They thought they knew everything and were positive the prickly problems on the periphery would sort themselves out. They couldn't be more wrong. The problems physicists faced revolved around weird observations about electrons, heat, and spectra. In this video, I will try to explain the first problem, how electrons were emitted by metals when light is shown onto them, and how it was eventually solved. Physicists set up this experiment so that they could tell if electrons are emitted, and if so, how many. We tried using red light, and no electrons are emitted. We tried with brighter red light, and still, no electrons are emitted. But when we tried with blue light, no matter how dim it is, a lot of electrons are emitted. How could this be? It's easy to see how light can kick out electrons because light contains some energy, but surely brighter light contains more energy than dimmer light. So how could changing the brightness of the light have no effect on the number of electrons emitted? That made no sense at all. Remember from physics class how electrons in the metal are bonded to the metal ions? The energy required to break those bonds is defined by the work function. Einstein proposed that light traveled in packets called photons. It's helpful to visualize them as tennis balls. These tennis balls have energies proportional to their frequency. Also, he said that only one tennis ball can hit one electron at a time. Therefore, if the energy of a photon is greater than the work function of the metal substrate, electrons will be kicked out. In other words, if the frequency of the photon is greater than a threshold frequency, electrons will be kicked out. This completely explains our observations, because red light's frequency is less than the threshold frequency of the metal tested, so no electrons are detected. On the other hand, with blue light and ultraviolet light and higher frequencies, lots of electrons are emitted. This phenomenon is called the photoelectric effect. Remember how Einstein explained the photoelectric effect by assuming that light traveled in packets? This meant that light is not what we previously thought it was. It can't be cut at any place you like because it's less of a stream of water than a conveyor belt of tennis balls. Einstein ended up winning a Nobel Prize for this work. Today we use the photoelectric effect to count objects on a conveyor belt in a stick figure factory, and in solar cells to generate renewable solar energy. In the next videos, I will explain the other two problems and put two and two together to form a greater picture, leading into modern 20th century physics. Thank you for watching.